Welcome back, everyone. In this lesson, we're going to discuss my favorite tool in GIS, the Spatial Join tool, and I'm going to show you how to use it to attach data from one data layer to another by its location in space. The Spatial Join tool is the proverbial Swiss Army knife of GIS. I feel like you can make it do anything that you need it to do, and that any sort of question or tool that you might use any of the many capable tools in Arc Toolbox for, you could probably make into a problem that Spatial Join can solve. I think this so much that my coworkers kind of joke that I'm the Spatial Join guy, because whenever somebody comes into our office and asks for help with a GIS problem, I'll say, well, yeah, you could probably do that with a Spatial Join, and they're oftentimes coming up with a more appropriate tool. If you have one geoprocessing tool that you remember and know how to use, I think Spatial Join should be it, because it's so capable of helping you in all sorts of situations. To understand how a Spatial Join works, I think it helps to understand what a standard table join is. And a standard table join takes two data tables and brings them together and attaches the attributes of one to another when they share a value in a common field. So maybe they both have the same field, but one has it in reference to the other table. So when you bring them together, it says, well, do they both have the value 5 in this field in one table and this field in the other table? Yes, okay, then attach all the attributes in the record for the second table to that record in the first table. If that explanation doesn't make sense for you, just note that we are taking data from one data table, and specifically records from one data table, and appending it to the record from another data table based on some relationship. And it can be an attribute relationship, or it can be a spatial relationship, like our Spatial Join tool. Joins in general are incredibly powerful and usually require some sort of sophisticated database management system to run them. But spatial joins in particular are a really unique feature of a GIS, a spatially aware database system of some sort. I want to just give you one more comparison to help you understand what we're going to do with the Spatial Join tool. Remember when we did the Select by Location tool and we selected features where they shared some sort of relationship to another set of features? Well, we're using the same document here, and what we're going to do with Spatial Join is basically the same thing, except for instead of selecting the features, we're going to take the features that have that relationship and append the attributes from one to the other. This is really useful if we want to continue the analysis with some additional data other than just the feature information. Okay, so let's do a Spatial Join. In Arc Toolbox, we can find it under Analysis Tools and Overlay, because we're basically overlaying one data layer on top of another and doing something with that information. And it's right here, Spatial Join. And it's a geoprocessing tool, just like we learned about. And I'll collapse Arc Toolbox again. And what I want to do now is I'm going to Spatial Join the county's information to the watershed information. I'm going to attach the attribute table information from the counties to the watershed so that we will know what county each watershed is in. This sounds like kind of a simple problem, but let's take a look really quickly down here. What happens when we have watersheds that cross the line between these counties? It's non-trivial to say that it's in a particular county. Well, Spatial Join accounts for that and helps us solve this problem. So we have our join features and our target features. Target features receive the attributes and join features give the attributes to the target features. If I forgot that, I could click on each field here and see in the help. The important thing here is that we're left with the geometry and initial attributes of these target features, and they take on also the attributes from the join features. So what I want to do here is I want to transfer the attributes from counties to the watersheds. So I'm going to select subwatersheds as the target features, and I will select the counties as the join features. And ArcGIS tries to helpfully select an output feature class for me based on the default geodatabase for this document. Instead, I'm going to put it in a different spot here, and we'll do Spatial Join Watersheds Counties. And down here, it offers two types of join operations, join one-to-one and join one-to-many. That gets at that problem I just told you about of what happens when a watershed is in multiple counties. How does it deal with that problem? In join one-to-one, again, if I forgot about it, I could read about it over here. But in join one-to-one, it says, okay, give me one result, keep just one feature for the watershed, but I can define a merge rule about how to deal with the attributes from these multiple counties that the watershed is in. If I did join one to many, the problem's a little simpler. Basically what it does is it just duplicates the watershed record and creates a record with all the watershed's attributes, and then the one county's attributes, and then another one that has all the watershed's records, and then whatever the other county's records are, and so on until it has duplicates of the watershed to account for all of the different counties that it might be in. In this case, we're going to do join one to one because I want to show you some merge rules. This next option down here, keep all target features, is really useful in a situation like this where I have a selection because I'm just working with a couple counties. And if we see, there are a lot of other counties around it and the watersheds extend into all those counties. But if I did keep all target features, it would give me an output that is all of the watersheds in the state because that's the whole layer. And then there would be county attributes attached only for the counties in the selection here because those are the only ones active in the join features right now. And every other subwatershed would just have a null value for all the county information. So what I might want to do, and what I'll do in this case, is I'm going to uncheck this box, and what it's going to do for me is it's only going to give me an output of subwatersheds that actually successfully joined to some counties. So I'm going to kind of subset my subwatersheds at the same time here. And next on down is a really powerful feature that I often ignore when I'm doing my own work, but it's a key part of using the join one-to-one option, and it's the field mapping, or how we set all the merge rules up for when we're trying to deal with those conflicts. And I can see that it has all the attributes from the subwatershed table, and then it has all the attributes from the county table at the end. This is kind of what we expect the output schema to look like. Now, in reality, if we were trying to join all of the county's information to the subwatersheds, we'd deal with each and every one of these. But for now, let's pretend we're only interested in getting accurate information on the names. So I'm going to expand this, and it just has counties.name here. But if I right click, I can set a merge rule directly right here. And so it could either use the first county it joins to or the last county it joins to, or we can just get the count of the number of counties it's in. But in this case, we'll use join, which is sort of a concatenation. It appends each county to each other. But I'm not going to set it here because I need to do something more advanced with it in properties. So I need to do two things here. Number one is I'll set it to join so that if a subwatershed is in multiple counties, it gives me all of the names of the counties in one field. And then I'll set a delimiter so that instead of just kind of putting it as counties back to back, it'll give me them in a comma and space separated list. The other thing I need to do is change the output field length, because otherwise it's going to run out of space to put all these counties together and it'll just fail. So I'll set that to something really large right now because I don't know how long they'll need to be in this case. So I'll set it to 1,000 and that'll be plenty of space. And what I might also want to do while I'm here is change the output name, because once I'm joined, I might get confused about whether or not the name field is for the subwatersheds or for the county. So I'll change it to county name. And I'll change the alias to county name too. And then I'll click OK. And this is basically rewriting my data table here based upon all this input. And that's really handy to be able to handle all these merge rules. What's really cool is you can also do it with quantitative fields. So in merging a field that has numbers, I get some other merge rules. So I can get it to just sum them all up or give me a mean or standard deviation of those fields. So I get some really powerful options for dealing with multiple counties per item. Last up down here is something you're going to recognize. It's the match option. And this looks a lot like the select by location match options, except they're just written differently. But the nice thing is that even though they're written differently, if I look at the help over here, it describes exactly what they all do. And it's pretty much the same list. And you have a lot of different options for specifying the relationship between these features in order for them to match up to each other. I'm just going to leave it as intersect for now. So I'll click OK now and run the tool. And it's running down on the bottom here, and I can check on it in results if I want to. And Spatial Join is also surprisingly fast for the amount of work it's doing. So it's already done. And so I can collapse it, and it added a whole new layer to my map document for me. So let's zoom to that layer. So let's just zoom down into this corner and take a look at some spots that would have multiple counties per watershed here, as in this one. And first note that it left out the features that didn't get a join successfully, just like we expected. Everything out here, and then also even this one kind of tucked in between these other watersheds, it was left out. But then let's take a look at one that wasn't in multiple counties and just identify it and see what happened to the attribute table. So if we scroll down, we can see all of the watershed information and then also all of the county information, including our rewritten name here, county name, and it says Los Angeles County, which is what I'd expect. But then what happens if we take a look at this other watershed right here? Let me just scroll over to make it easier to see. If we look at this one here, which is in multiple counties, I'll click on it and I can see again, it has all the attributes of the watershed and all the attributes of the county, and then county name, and it says San Bernardino, space, Los Angeles. And that's because it joined the two together in a different way than our spatial join, but it joined the values together, and it put in the one county name, and then when we put that delimiter of space, it then puts that between any multiple values to attach to this. This kind of functionality is really useful because it allows us to bring all sorts of spatial information together based upon their relationships to each other, and then rewrite our attribute tables in ways that make sense for the project at hand. So that's it for this demonstration of spatial joins. I would really love to spend all day showing you all the cool stuff you can do with a spatial join, but I think if you think about it, you'll find you can apply it to almost any project you have. And in fact, what we're going to do is we're going to put in a discussion question right after this video, and just it's optional, but it's a spot for you to think about and read about people's potential uses for spatial joins. So I hope that you'll participate there and think about some potential ways you could use it in your own workflows. In the meantime, I'd like to give you some ideas for some other ways you could use spatial join besides what we just did here. So one thing you could do is if you had some population level data that's at some really small unit, like from the census, and it's stored on these small polygons, but you wanted to aggregate it up to the county level, you could do that with a spatial join and have those summarization options for a field add up all the population information into the county. You can also take a rivers layer and a roads layer and figure out which roads cross a river and get that information of the roads crossing the rivers as an attribute on the rivers. And then a much more common use would be if I had some parcel information and I wanted to attach information to it about different utility districts, water districts, what election districts it's a part of, and what counties it's in. I could just do a bunch of spatial joins to attach that information from these other feature layers back down to those parcels. So those are just a couple possibilities for what you could do with the spatial join. As I said, it's the Swiss Army knife. It's super versatile. There's just so much that you could do with a spatial join. So just a quick recap of what we learned in this lesson. We learned how to use the spatial join tool to attach information from one attribute table to another based on the spatial relationship of the features involved. And as I said, go take a look at that discussion question. I'll see you there.